Benchmark fractions is our topic today, and these are fractions that we can use to help order fractions. Some of the ones we'll do, they'll be so close together that it'll be really hard to tell which fraction is bigger, but in a lot of cases, you'll be able to tell just by using some simple techniques or using some simple things that you should know about fractions. The first one I want to show you is what it means for a fraction to be one whole, or exactly one whole. And in this case, examples of fractions that would be exactly one whole would be like something like 5/5. What this means is you've got your whatever you're starting with here. 5/5 would mean it's cut into 5 pieces. And what this means is 5 out of 5, you've got 5 out of 5 pieces. So you've got 1, 2, 3, 4, 5 pieces. So when I look at this, I have the entire thing. So if this was one of our brownie pans, that means I have 5 brownies out of the 5 that are cut into the pan, which means I have every single brownie. So for instance, another example would be if you had 8 out of 8, or if you had 100 out of 100. Doesn't matter how big or small the numbers are, if the top number and the bottom number are the same, that means you have the whole thing, no matter how many pieces it's cut into. So be on the lookout for a top number, a numerator, and a bottom number denominator that are the same. That represents one whole. Another type of fraction to notice would be something that is more than one whole. And something that's more than one whole is going to look like this. Like, for instance, 3/2. Basically, with 3/2, what we're saying is we have a pan that's cut into 2, if we're doing brownies again. A pan that's cut into 2. That bottom number is always how many it's cut into. And it's telling us that we not only have 2 pieces, we have 3 pieces. So that means that we've got these 2 pieces, and then we'd even have to get out another pan that is cut into 2 and give ourselves one more. So if you think about it, we have 3/2 here, and we have 1, 2, 3/2. So this is more than one whole because we have an entire pan here to ourselves, plus we have this one extra half a pan right here. So this is more than one whole. Other fractions that could be more than one whole, like 6/4 is a good example of something that's more than one whole. 100/6 would be more than one whole. Anytime the top number is more than the bottom number, or the numerator is bigger than the denominator, your fraction is going to equal more than one whole. The next one we'll talk about is exactly half. Um, if we have an example of exactly half, would be like 5/10. If I have my brownie pan, and we'll see if I can cut her into 10 here. There's 1, 2, 3, 4, 5, and cut it in half would make 10. So if we have 5/2, 1, 2, 3, 4, 5. That's the exact same thing as having exactly half. And if I draw another pan here, and I just cut it like this, you'll see that these two things are the same. They take up the same amount of space. They're both half. So to identify if a fraction is exactly half, you just have to have the top number be exactly half of the bottom number. So 5/10 is a good example of something that would work. Another example would be like 3/4 would be a good example of something that would work. Not 3/4, 3/6 would be a good example of something that would work. 7/14. Anything where that top number is half as big as the bottom number. So I'll give you some examples. I said 7/14, 3/6, 100/200. Again, it doesn't matter how big or how small these numbers are, like the top and the bottom, how big or how small they are. It just depends on what part of the fraction they are. 7 is half of 14. 3 is half of 6. 5 is half of 10. 100 is half of 200. So all these fractions represent something that is exactly 1/2. Our next one we'll talk about is something that is more than half and something that is less than half. So an example of something more than half. Let's say it's out of 8. oops, not 3/8, that goes down here. 3/8 is something that would be less than half, where 6/8 would be something that is more than half. And how I find that out is if I take the bottom number, which means we'd have something that's cut into 8 pieces. 6/8 means that we've got more than half of those pieces, because exactly half would be 4/8. It's always good to find exactly half. So 6 is more than 4, so this is going to be more than half. 3 is less than 4, so this is going to be less than half. And other examples we could use, I mean, there's an infinite number of examples here, but let's say it's something that's out of 20. 15/20 would be a good example of something that is more than half. 2/20 would be something that is an example of less than half. If you think about a brownie pan cut into 20 pieces, if it was 10 out of 20, you'd have exactly half. But 15 is more than 10, so it's more than half. 2 is less than 10, so it is less than half. A couple more that I'll get through. The first one is, what happens when you have the same denominator? So for instance, same denominator, so say like 3/12, 4/12, 6/12. These are really easy to put in order because, and we'll talk about something called common denominators later on, which makes fractions easier to put in order, but we've got something cut into 12 pieces. Could be brownies, it could be sometimes pizzas cut into 12 pieces, but if they're all 12ths, then we just pick the biggest one. We just pick the biggest number, and that would be the biggest fraction. So 6 out of 12 is bigger than 4 out of 12, which is bigger than 3 out of 12. If we have the same bottom number, we have the same amount of pieces, the same size pieces, so we just want to decide, well, which do we have more of? 6/12 would be more than 4/12, and it would be more than 3/12. Another example is, if all your fractions, let's say you have 4 fractions, then they all have, I don't know, it doesn't really matter, 99 is your bottom number. If 99 is your bottom number and it's the bottom number for all of them, that means whatever you have is cut into the same amount of pieces. So, I mean, I could go 3/99, 10/99, 20/99, 33/99. This one's going to be the biggest one. It's cut into the same amount of pieces all the way across, and we have 33 of these, where here we only have 3, and here we only have 10, and here we only have 20. The last one I'll cover here is same numerator. And what same numerator means is, like, if we have 3/10, we have 3/8, and let's say we have 3/4, and we have to decide which one of these is the bigger fraction or which one is the smaller fraction. There's a couple of ways to think about this. First of all, what I like to do is, if we have the same numerator, just think about which one of these is closest to being a whole thing and which one of these is closest to being nothing if you have the same numerator. This is only one away from being a whole thing, where this is 5 away and this is 7 away. That's generally a way that you can kind of think about things, but probably the better way to think about these would be to think about what are the sizes of the pieces that you're actually getting here. So what I mean by that is, if I cut this one into 10, and I've already done something into 10 here, but if I cut this into 10 and I do something that it's got to be the same size or roughly the same size, and I decide to cut something into 8, okay, that's into 8, about the same size. I'm not the greatest at drawing here, but we'll do our best. And 3/4. Now, if you take a look at this 3/10 has the smallest pieces. This 3/4 has the biggest pieces. So if you're trying to compare these fractions, and we have 3 of all of them, you'd want 3 of the biggest pieces. That would give you the biggest number. Or if you were looking for the smaller fraction, you'd want 3 of the smallest pieces. So if I go ahead and fill these in, 1, 2, 3 of these, compared to 1, 2, 3 of these compared to 1, 2, 3 of these, I definitely get more with this one because I've got bigger pieces. I'm still getting 3 pieces. I'm getting 3 pieces in all of these. But I'm getting more with this one because the pieces are actually bigger. I'm getting less with this one because the pieces are actually smaller. Everything I've talked about today, as far as what's a fraction that looks like one whole, more than a whole, a half, more than less than a half, same denominator, same numerator. These are all techniques to put these in order. You'll find after this video a sheet that gives you more examples of fractions that fall into this category. Please make sure that you write down those examples as well before moving on.